Hey everybody, it's Mr. Carr again. Today we're going to be talking about 4-3 day 2. We're going to continue our solving quadratics by factoring by actually solving our quadratics. Before we do that, let's start with real quick one more factoring example here. Factoring, it says factor trinomials, but that's not what we have here. So just like we did before on the previous day, if I have 4 terms, like I have 2 and I have 2, we can do this as a factor by grouping. Meaning, I'm going to look at what GCF can I take out of these two, and then I'm going to look at the GCF here, and let's see what happens when we do that. So 32 and 40, they have 8 as a GCF, and XY and BX has an X as a GCF. So what's left is going to be 4Y plus 5B. Okay, and that's me factoring 8X out of both of these terms. From negative 12AY and negative 15AB, we could take a negative 3 out, and we can also take an A out. So what's left is a positive 4y and a positive 5b. Since this matches up to that, then technically I am factoring that out to the front like this, 4y plus 5b. And then what's left is 8x and a negative 3a, so I can put that in here. So I can still do my factor by grouping. If you have 4 terms, check to see if you can do the factor by grouping. And what that means again is set them up as two sets of 2 and look at them that way. Okay, for our next example, now we're going to talk about the solving. This is very similar to what we did yesterday with just factoring, but now we're going to take it a little bit further to actually get to the solving idea. So when my trinomial equals 0, the first thing I want to do is look for GCF. In this case, it's 2. Now, normally I said factor a 2 out, but in this scenario, because it's equal to 0, everything is divisible by 0, meaning I can deal with a smaller version, which is x squared minus 6x plus 9 equal to 0. So that's a little easier to work with now. So now we go through and do the factoring of that. So we look for what fits our pattern. So x squared minus 6x plus 9, we know we have to have x and x. Multiplies to a 9, but adds to a negative 6 is a negative 3 and a negative 3. Now, in this scenario, this is the important part about solving. This is what's called the zero product property. And that is if I take 2 numbers multiplied together and the answer is 0, then if in the scenario of A times B equals 0, either A equals 0 or B equals 0. Okay, that's the only way for this to work. So in this scenario, it doesn't really matter, they're the same thing. But if I have x minus 3 times x minus 3 and that equals 0, either x minus 3 equals 0 or x minus 3 equals 0. Like I said, same thing. I solve this real quick. I get x equals 3. And I'll get it either way. So that's my answer is x equals 3. Okay. We'll get 2 answers when we do something like this. Y squared equals 36. There's a little bit of a shortcut here. Just real quick, just because I just want to demonstrate it. If I have y squared equals 36, then this is the square root property, which means we take the square root of both sides and we get plus or minus 6. Okay. So we know that I'm going to have 2 answers. It's going to be a positive and a negative. In terms of our factoring, first thing we want to do is we want to make it equal to 0. So I subtract 36 over. Then I do my factoring and I treat it like it's a 0y in the middle. So this is a difference of perfect squares. So it ends up being y plus 6, y minus 6. According to zero product property, this y plus 6 can equal 0 or y minus 6 equals 0. Solve them both, I get negative 6 and positive 6. And that's the same thing as over here. Okay, so y equals 6 and y equals negative 6. Factoring this one, whoops, don't get to the answer yet, but you already saw it, but oh well. Okay, a little bit more complicated, but again, do the factoring. First thing is, before I can solve it, it's got to be equal to 0. That's the goal with solving. Okay, this one I could do as a guess and check, and I think I will in this case, but don't forget you can also do the AC method, where you take the 5 times 14. So I know with 5x squared, it has to be a 5x and an x. Okay, for that one, for 14, I think it's going to be a 2 and a 7. We've got to multiply to 14 here. But I think it's going to be a 7 here and a positive 2 here. So remember, 2 positive signs means I have 2 positive signs here. So that helps. 14 could be 1 and 14 or 2 and 7. But with a 7 here, I'm going to recognize that 5 times 7 is 35. 2 times 1 is 2. That adds up to 37. So my guess and check here is pretty straightforward. With my with my zero product property now, I can take 5x plus 2, set that equal to 0, and then x plus 7, set that equal to 0. This one's easy. I just subtract 7, so I get x equals -7. Over here, I'm going to subtract 2, so 5x equals -2, but then I also have to divide, so I get -2/5. So that's my two answers here, -2/5 and -7. Okay. Here, we're just going to give it a little bit of a diagram. Find the value of x. So we're doing the area of a rectangle, which is going to be these two multiplied together. So here's how that looks. The area of the rectangle is x minus 2 times x plus 2, and that equals the overall area of 96. For our purposes of factoring, before we can get to that, we're going to go ahead and do our distribution and turn it into a trinomial. So that means I'm going to distribute the x, distribute the -2. So we have x squared. -2x and +2x actually cancel out. Then I'll have a -4 after that. Okay. Then I want to equal to 0. So we subtract 96 over. So x squared minus 100 equals 0. And then now I can do my factoring. Because it's the difference of two squares, be -10 plus 10. I could solve them out separately. So x minus 10 equals 0, or x plus 10 equals 0. So I get x equals 10, or x equals a -10. Now, when I look at my problem, because I'm doing the area of this rectangle, if I try to plug a -10 in, that's not going to work. I can't have a side length that is -10 minus 2 is -12. So this actually, I don't care about that answer. I only have one answer for x, and that's 10 in this case. Okay, so we can get rid of a -10 here. Just a +10 is my only answer that works. Okay. Now we're going to work backwards a little bit. Write a quadratic equation in standard form with 1/2 and -5 as its roots. So roots is another name for these solutions. How that looks, remember, what we're saying here is my final answers were x equals 1/2, x equals a -5. From the previous problems, we saw that before I got this, this was equal to 0. So for example, this was the result of having x plus 5 equal to 0. 1/2, I could do the same thing, x minus 1/2 equal to 0. But now I'm dealing with this one, like a fraction here. We didn't have that before. That means I'm going to multiply everything by 2. So it's 2x minus 1 equals 0. These are my factors. So I can now turn this into a quadratic if 2x minus 1, x plus 5, and that was still technically equal to 0. Now I just multiply this out and distribute it. So we got 2x times x, 2x times 5. We have 2x squared plus 10x, -1x, -5. Put my like terms together, so my quadratic is 2x squared plus 9x minus 5 equal to 0. Okay, that's us working backwards from the roots idea. And that, oh yeah, we'll just do this one as a factoring idea. So the entrance to an office building is an arch in the shape of a parabola, whose vertex is the height of the arch. The height of the arch is given by this equation, where x is the horizontal distance from the center of the arch. So very roughly speaking, it looks like this. Okay, that's my height, or sorry, that's my x. And then this is my height idea, okay? Both h and x are measured in feet. How wide is the arch at ground level? So at ground level, the height is 0. We're looking at where's this spot at. So that's what I'm going to set up as 0 equal to 9 minus x squared. So if I solve that out, I can do my factoring. It's actually another difference of two squares. So it'd be 3 plus x, 3 minus x. Solve them separately, I get 0 is equal to 3 plus x. Subtract that over, I get -3 for x. And then I get 0 equals 3 minus x, and I can add the x over, so x equals 3. So at ground level, that means this is 3 over here. But if we're talking about the whole arch, and sorry, I should mention, again, just like before, -3 doesn't have a realistic idea. Not in terms of our quadratics here. We don't care about the negative sign because that's just telling me that I'm kind of going to the negative direction. which is kind of helpful, but it's more important that we just say that it's 3 away from the center. But it also means it's 3 away this way. So the total width is 6, and that's my answer. The arch is 6 feet wide at the bottom, because we can go 3 and 3 from the center. Okay, and that's it for 4-3 day 2. So that's our practice problem for this. Feel free to ask any questions. Remember, the big main idea today, let me go back real fast, is right here. Zero product property. If you have factored form equal to 0, so it has to be equal to 0 and it has to be factored, we can do the zero product property, which is splitting them up and setting them both equal to 0. Okay, and that's our solving method for today. All right, take care, everybody.